they can come back. We shouldn't get too comfortable because we know these lampreys can quickly adapt.
Sea lamprey are eel-like fish that invaded the Great Lakes about 100 years ago. They attach to a fish and they draw out the juices of the fish, leaving essentially the husk. Great Lakes Fishery Commission is a binational organization, so Canada and the United States. We have a binational science program that we execute each and every year, as well as a mandate to control the invasive sea lamprey predator. In the 1950s, sea lamprey were running rampant in the Great Lakes, to the point where certain species of fish went extinct. Our research revealed back in the 50s that there was a compound that lamprey can't metabolize that Great Lakes fish can. That led us down the road to a lampricide. Through our control efforts over the last 60, 70 years have yielded really positive results. Sea lamprey populations are down by over 90%. We have a very rigorous program to refine how we use lampricide, but also to find if there are other methods of control.
CRISPR can be used to do a number of things. One of them is editing the genome, and that's what we have been using it to do so far. Our lab is really focused on trying to develop the technology for understanding lamprey biology and specifically looking for vulnerabilities in their biology. An example of one of the major things we're interested in is what the mechanisms are underlying their sex. So what makes them male or female? There's a lot of exciting work to come out of it, and potentially some things that we could leverage in sea lamprey control in the distant future. It ranges from ways to generate sterilized males all the way to ways to make populations male or female. But at this point, we're really too far from that. One of the tricks is we only have lamprey available to do some of the first steps of these experiments in the summertime, during their natural spawning season. So you kind of have a limited window that you can start the experiments. The methods to raise lamprey for extended periods aren't well developed. We have colleagues at Hammond Bay and also here at MSU who are trying to develop those methods.
SLAP is an acronym for the Sea Lamprey Aquaculture and Procurement Initiative. It's an initiative we started a couple years ago with our partners at Michigan State University and the Great Lakes Fishery Commission and many other agencies to develop protocols to complete the sea lamprey life cycle in the lab. And we can also have a consistent source of sea lamprey for research, especially those that are hard to acquire, like the large larval stage, and also those that have gone through transformation and are feeding on fish. And I don't think anybody in the world yet has completed the life cycle of lamprey in the lab. That is, in essence, our moonshot. And what we don't know and what we're looking forward to learning more about is how to best keep the parasitic life stage that wants to feed on fish and consume blood in the lab. A sea lamprey will kill about 40 pounds of fish each. So even if you're trying to rear 100 to the adult life stage, we simply don't have access to that many fish, and our labs aren't big enough. So we're going to need to think creatively about how to develop an artificial feeding system or artificial foods for these parasitic lampreys. If we get to the moonshot, which is being able to have a protocol that clearly describes how to go from embryo to adult in the lab so that you can see the outcomes of CRISPR-edited lampreys, I think we should be there by 2028 or 2029, if it's possible. We need to be thinking decades in the future as far as what the future of control would look like so that we can be well positioned to continue delivering effective sea lamprey control in the Great Lakes.